everyone, we are really excited to present to you the long-awaited Protosynth Midi. It has taken nearly 3 years of development to figure out how to get some of this super epic functionality into this product, and we are finally able to release this to all of you. In this video, we'll be showing the basics of what the Protosynth Midi can do for you and a little demo just to whet your appetite. Each of these are hand soldered, hand assembled, hand sanded, and of course tested thoroughly before each release. So we hope you enjoy getting a look at what the Protosynth Midi can do. So we'll start by showing you guys the power indicator or the power switch. Simple toggle on and off to turn it on and off, and the light. Yep, the LED will turn on when it is on. Then we have our MIDI channel selector. And this dip switch actually chooses 2 out of the 16 MIDI channels that you can monitor.
Channel A and channel B.
Correct.
4 bits for each one.
Right. And the bits are determined in right to left from least significant bit to most significant bit.
Yeah, least significant bit is on that end. 2 groups of 4.
Okay. Got it. Yeah. So then you just choose by binary.
We have the logo, which everybody seems to love.
Well, I like it.
It was an inspired moment.
It was.
All right. And then down here we have the back panel jacks, and this allows you to tap into the 1/4-inch jacks that are on the back of the unit. There's 4 jacks back there, and on each of them we can attach breadboard wires in for tip, ring, and shield on any of the 4. And let's take a look at the back, and Addie can point us out which jack is which and what else is back there.
And we have jack number 1, jack number 2, jack number 3, jack number 4. MIDI input, power input. In all 4 jacks, you can use a 1/4-inch cable. TRS or TS would be fine.
So here we have the Toymod Shift Me V1. And basically what this is a input and an output interface that's compatible with the Protosynth Midi. You've got 2 different types of shift registers. One is, serial to parallel out, and one of them is parallel to serial in. And that second functionality we're not going to deal with right now. Right now what we're mostly worried about is the serial to parallel out. The serial is coming from the Protosynth Midi, and the parallel out is coming to those LEDs right there. And we're going to show you how to control those with your Protosynth Midi. So looking at the header here, you can see that we have switch latch, switch clock, switch serial, LED latch, LED clock, LED serial, VCC, and what is that, VDD?
VSS.
VSS, sorry. This is one of our oldest modules, so the order here is a little bit different than what we use now, but it's completely compatible. We're not going to be using the switches, as that would be going from the switches into the Protosynth Midi. We'll cover that later. Right now we're going to cover how do you get these LEDs controlled by the Protosynth Midi. And that is through making sure that the ground pin of this module is connected up to the ground of the Protosynth Midi, and that the serial connections of clock, latch, and data are all hooked up. Data on this module is listed as LED serial, but we're going to start with the Protosynth MIDI standard, which is clock, latch, data, in that order. So Addie, if you could do yellow into the clock, green into the latch, blue into the data or serial, connect up the ground, and the power, we're going to put power on purple.
Purple power.
Yeah. All right, so that side is all hooked up. Now let's go over and hook up the other end to the Protosynth Midi. Addie's going to help me hook these up real quick. As we were saying, we picked the yellow for clock, the green for latch, and the blue for data. And those are going in MIDI channel A, the note port, clock, latch, and data. And for the power, the gray one is going into the ground, and the purple one is going into 5 volts because this module can handle 5 volts. And it's that easy. Now our Arturia Beatstep here, and I want to make it clear this could be any MIDI controller. We just happen to be using this one. The top row at the moment is programmed to output on notes 0 through 7 of MIDI channel 1. MIDI channel A here is assigned to MIDI channel 1 up on the dip switch selection. So if I were to turn note 1 on, note 1 coming out of the MIDI channel A note port does indeed go on. Same with MIDI 2, 3, 4, 5, 6, 7, 8, and you can of course do more than one at a time. So that's using the MIDI note port to use all of the note on and off commands that are happening on the MIDI channel. Now let's move these wires over and use the control port so that we can show how you can use changes on the MIDI control change values as well. And again here you can see that we've hooked clock, latch, and data up to clock, latch, and data. We didn't have to move our power or ground. The same power or ground will work obviously. And what comes out of this port is every single control value on that MIDI channel, its value at the moment, in binary, 7 bits at a time. And there are 127 of them. So the first one that you connect here ends up on control 1. And so let's zoom out here and show what that looks like when you're applying it to some binary output lights. So we've moved this over to the control port here, and I have this program so that this knob right here will change the value of MIDI control value 1. And I see you're reaching for it, so I think I'll just let you go ahead and do that. And as she turns it, you can see it counts up on the lights in binary.
That's cool.
And while this isn't terribly useful for anything practical, we can show you guys what you can do with this 7-bit number that's coming out and actually do real interesting stuff with it. That's more interesting than just counting binary, because I mean, why do you need to do that?
Because of the lights.
Eddie seems to really enjoy doing that. You can go really fast, by the way. You're not going to confuse it. Blinking lights.
Voila.
So we swapped out the Shift Me for the analog shift module. And it is wired up the same way. The clock, latch, and data off of the MIDI control port is wired over to the clock, latch, and data on the analog shift. Now the analog shift is a smart module. It has a microcontroller on board. It accepts the 7 bits that we showed you on the Shift Me, but instead of turning on a bunch of lights on and off with it, it's actually taking whichever voltage you're providing to power the module and dividing it into a linear 128 steps. So you can see the output of the CV pin on the analog shift is connected up to the multimeter, and we presently have 6.5 millivolts reading. And if I were to change the control value, it goes up by 1/128th of 5 volts because we're powering it with 5 volts at the moment. You could power it with 3.3 and it would be a 128th of 3 volts. But we can adjust our voltage analog voltage by changing the MIDI control value all the way up to almost 5. 1/128th of 5 volts shy of 5 volts. That's how it works. And with this, you can do really, really cool stuff. And I hope that helps you understand why the control port is so powerful. It allows you to get analog stuff out of a digital protocol like MIDI. And I believe Eddie now wants us to show how these modules can chain together in a row. Okay, so remember how I was saying that we have 128 MIDI control values on each MIDI channel?
Yep.
This is where that comes in to play. I have here, just as we showed before, the analog shift coming out of control port A. Connected to it over here, its port outside, I have connected the Shift Me. The same way that we did before, except the Shift Me is now connected to the analog shift instead of directly to the Protosynth Midi.
Right.
Okay? Now what this means is that this is the first item in the chain of modules that's connected to control port A, and that is the second item connected to the chain. I have on the MIDI controller this assigned to MIDI control value 1, this assigned to MIDI control value 2. So now, in theory, the first item in the chain gets MIDI control value 1, second one in the chain gets MIDI control value 2. So if I were to adjust this, we should still get our voltage changing.
And we do.
There's 1.324 volts. But now, if I were to change this knob,
You still get the LEDs.
we're counting up in binary on the second module.
Right.
And I hope this illustrates just how much more powerful that makes this. You can pick from any of the modules that we sell and make. You can make your own. These are just shift registers. It's simple stuff. If you're into electronics, you know what I mean. You could have 2 different modules. You could have 6 modules in a row. It doesn't matter,
Or 120.
right? Once you get up to super long chains, there's probably some like power issues and things you're going to have to figure out.
Right.
But for short chains, absolutely no problem, just powering straight off of here. But to illustrate how powerful this gets so quickly is that if you were to hook up a chain of analog shifts, think about it. That's 128 analog voltages that you can control individually. That is extremely powerful tool. You can do crazy stuff with that. Let me reiterate, that is crazy. Now, there is another way to get analog voltages out if you have the full Protosynth Midi. This isn't built into the Protosynth Midi Lite, so this is one of the reasons why you may want the big one if you want this functionality. I have built in here an analog section. So MIDI control channel A, analog section. We have CV, gate, and trigger. All right. When you press down a note, gate and trigger go high. Gate stays high as long as that note is on. Right. CV is related to the last note that you pressed. So if I press this note, CV is an analog voltage showing on the meter there, presently 5.6 millivolts. And that's basically MIDI note 0 in this scale. This particular one behaves just like the analog shift, but it's powered by 3.3 volts. So your scale is 0 to 3.3 volts. So do your math around that. You can buffer it, amplify it to get CV for any equipment you want. 1 volt per octave, any of those sorts of things. You have an accurate linear division of 3.3 volts coming out of that CV. So that's note 0. If I were to press a note higher up the scale, notice the voltage changes. We're now at 286.7 millivolts. If I were to press that note, 208.6. And mind you, it's the meter that's slow, not this. This changes voltage very, very quickly and is very accurate. We have tested it and tested it. So basically what this does is every time a new note on command comes in over the MIDI, that voltage changes to whatever note that was. And it stays until another note is pressed. And you'd use the gate and triggers to do your ADSR triggers, anything like that. So this just says what frequency we're on. The gate and trigger says at what point in the volume envelope we should be. Should we be attacking, sustaining, decay, release, all that sort of stuff. So this is super valuable and it's built right in. This is for the people who want to build an analog synthesizer right on these breadboards. Perfect for that because it's functionality that's all built right in. You don't need an analog shift. You have one built in here. If you need more than one analog voltage, you can just chain analog shifts off of the control voltages or anything you need for controlling your filter roll-offs and stuff like that. But this one's good for controlling your voltage controlled oscillators especially. So Addie reminded me that we can probably actually show the gate and trigger in operation here. The gate's really easy because the gate just goes up to 3.3 volts whenever a note is pressed. So, well, she's going, so there you go. There you hold down the note, 3.3 volts. Very accurate. Thank you, Addie.
You're welcome.
The trigger, on the other hand, is a very fast pulse. So we hooked a little oscilloscope up, but it's so fast the scope may not catch it. So we'll just spam buttons here a bit, and hopefully when it'll come by on the screen, you can push buttons too, Addie.
Oh, I saw a bunch.
Yeah. So it's a really fast pulse. And that, again, that's at 3.3 volts, and it's just a super short pulse. And that happens whenever a note is pressed. So we've completely covered everything on MIDI channel A. And all of the same exact things are on MIDI channel B.
Just in case you didn't have enough.
So we don't need to recover all that ground. Just know that up on the dip switch, you can set MIDI channel A to be any of the 16 MIDI channels, and you can set MIDI channel B to be the same number or a different number channel. So they could both be copying each other, which could be useful, or they could be set to different channels and be doing completely separate things.
It's like stereo effect.
So what we're going to do is, real quick, build a little synthesizer on this using some of the functionality we've shown so far. So we quickly put together a synthesizer here, and what we have are, off the MIDI control port A, are a chain of 3 modules, 3 analog shifts, 1, 2, 3. And the CV on them, instead of going to a multimeter as we showed before, the CVs are going to 555 voltage controlled oscillators, one of the modules that we sell. And basically what that means is as the control voltage changes according to the knob, the frequency that the oscillator is oscillating at changes as well. And then the output of these 555 oscillators is going up to the first 3 inputs on this AND8 module. And that AND8 module is another one that we sell. Basically, it's a set of AND gates, and you're ANDing the bits that come out of the note port A with the bit being high or low off of the 555 VCO. This is a square wave oscillator, so square wave is on and off's there. So basically what happens is if you have this pressed down, one side of the hand gate is turned on. So whenever the VCO turns it on, they're both on, so the output turns on for that one. And that's hooked up to, like I said, MIDI channel A note port. So basically these 3 buttons turn the notes on and off. The outputs come out the other side into a Mix 8, which is another module that we sell. The output of the Mix 8 is going to Jack 1, and Jack 1 is jacked into the back. You can see it there. It's heading off to the recording studio, going through some reverb, and coming back here so that you guys can hear it. So if I press that, we have a note. Push that, we have a different note. And we have another note there. Addie picked these notes, so I'm not going to change them just yet because I think that while we were setting this up, she may have wrote a bass line.
Maybe.
So let's see what Addie does.
Oh. And that's all 3.3 volts, right?
Yeah, it's also reading out the frequency on the screen there.
I'm watching the square waves.
Yeah, it's got the square waves, but it's also figuring out which frequency they're going at down in the corner.
Awesome. All right, so again, it's these three knobs that adjust. Oh man, it's hard to stop.
So that's all the way down already.
Yeah. See? So of course, if you know where the positions are in your MIDI controller, then you can on the fly do the note switches just with a quick switch.
You could also control all these settings from your digital audio workstation over MIDI as well, so you could program this to play it without any of the human/Addie errors.
There is no such thing as errors on mine.
Yeah, but that's what you can build with this in a couple of minutes with some modules. And you can see we didn't have to build any circuits on there. There's no gaps or resistors or anything like that. We just breadboard wire and the modules, and you can build a synthesizer really quickly and easily.
Yep.
So to cover the MIDI monitor and serial console, we've hooked up a small computer here running PuTTY, which is a serial terminal emulator. We have a USB cable running over to a USB to TTL serial adapter. This one happens to be the prop plug from Parallax. You could use anything that does 3.3 volt serial hooked up to ground, RX, and TX. And you will be able to talk to the Protosynth Midi from a serial terminal. And right now the Arturia is plugged into the MIDI port on the back. We've got power running to everything. And we're ready to go. So I am going to turn on the Protosynth Midi and we'll see what comes out on the serial terminal. There you go. So this is what it does after it's booted previously. And this is probably how it will look when you first get yours. Because I booted up at least once to test it right after we programmed them. So it shouldn't be the first boot when you get it. So this is the serial console of the unit. And when it boots up, it shows you which mode it's in, what each of the MIDI channels are set to, what offset each of those channels is set to for the notes. And that's kind of a complicated subject. We'll cover it in a little more detail in a second. How many ticks per pulse, and what mode this window here is in. MIDI monitor mode 1. And it lets you know that it's all successfully initiated. And I press H and we get all of the commands here. H is for this menu, M is for setting the operation mode. And if you hit M, you'll see that they're all listed. We started out in mode 1, which is Protosynth Midi, MIDI clock sync, and CV mode. And here's the other states here. For details on what all of these do, we'll cover them all in detail in later videos when we demonstrate them. And you can check the data sheet for the PSM for full descriptions on all this stuff. We're not going to go into too much detail here. Just showing you that there is a serial console and you can do really powerful stuff in here. The main thing we're in here for today is that we want to show live MIDI monitoring of what the Protosynth Midi is getting from whatever MIDI device you have attached to it. So we saw that we're in MIDI monitor mode 1. So I can pick on this console, is it only a console or is it console plus MIDI debug? So MIDI mode 1 is with the console and the MIDI debugging, which is what we're set to now. So if I were to press something on the Beatstep, we're going to see it live here on the screen.
Cool.
Press a button. Now I'm going to turn one of the knobs.
That's useful.
Yep. And you note that it says channel 0 instead of channel 1. That's because they're labeled in the actual protocol. They're 0 through 15. But when you write them down for humans, you write them 1 through 16. These are listed at the protocol level numbers because most of the people who are interested in this feature are programmer types and whatnot, where you're actually debugging what's coming out of your MIDI controller. This might be a really useful tool for somebody who wants to build their own MIDI controllers and then test them with their Protosynth Midi and really see what it's doing under the hood. So you can see as I press buttons, you get immediate response on that serial console. Make changes here. They come out live as well.
Cool.
Very handy tool to know that it's in there. Okay, so presently we have an oscilloscope hooked up to the ground pin for reference, and under the advanced sync and input, we have it connected to clock. And this is kind of fun if you have any equipment that accepts a clock pulse. In the future, we're going to be demonstrating how this can be used to use MIDI to sync up your Game Boy that's modded, or your pocket operators from Teenage Engineering, and whatever else we come across that needs a nice little sync pulse coming into it. And I'm just going to demonstrate real quick by we were using the control functionality of the Arturia. Now we're going to use the sequencer functionality here. Basically, when I hit the play button, it is going to send the changing note values of each one of these 16 steps over to the Protosynth Midi. But at the same time, it's going to be sending MIDI clock pulses. And in our serial segment on this video, we explain how you can set how many MIDI ticks per pulse coming out of this clock pin. Right now, every single one's coming out, and I'll just press play. We won't see them all because it's very fast, but you'll definitely see some pulses come by. And you can see they're synced up with as the light's changing there.
So this helps you use...
This allows you to sync whatever circuit that you're putting on the breadboards up to whatever's coming down the MIDI pipeline.
So you can turn on a light whenever the MIDI beat or
Your
clock.
circuit can keep track of where you're at in the song.
Gotcha.
So the latch pin comes up and drops when the song first starts, and for each MIDI tick, the clock goes up and down. So your circuit, say you're using logic gates and stuff like that, can actually keep track of where you are in the song. Like if you were going to be building a sequencer on your Protosynth Midi breadboards that you wanted to sync up with your digital audio workstation on your computer or your outboard, stuff like this.
So that's a rundown of all the basic features of the Protosynth Midi. Be sure to check out the datasheet for more detail, and don't forget to subscribe at youtube.com/TYMKRS. We will be posting regular videos showing tips, tricks, and cool hacks made possible by the Protosynth Midi. Protosynth Midi, Protosynth Midi Lite, and all compatible modules are available for sale at tindy.com/stores/TYMKRS, and in-depth technical information about this and all of our products are available at tymkrs.com.